yesterday we were going over, or we had some homework to do. We had to update the links on at least elevation 2, maybe the rest of it. I just did elevation 2. Made taglines for the T-clips and F-clips, and used the BIM model to position any fixed length parts that can't be positioned with layout. So hopefully you guys had time to do that. This is what I came up with. You can see here that I've added these short little taglines, which are kind of hard to see amongst the mark numbers. But each one of these is either a T-clip or an F-clip. Just to look at the data, I put them under a sort of fake detail number because I don't really anticipate these. I don't want to have to duplicate these anywhere into like different details. That just seems silly. I also don't want to think about what detail number it should be. So I just piled them all into some miscellaneous detail that I called miscellaneous stuff. I made a different use for each variation of the T-clip. They're oriented differently, so that alone would make me have to do a top and a bottom. But also the hole sizes will be different, so they kind of need to be separated anyway. I got T-clip for the top and bottom at the corner, and then F-clips for the jam. I didn't do the right side. I just did top left and bottom left because elevation 2 didn't have the right side F-clip. So what I did for these, put in the part number, put in the fixed length, and in the BIM model, I rotated it so that it would be in the right place, which you can see here. If this thing ever will swing around. So here you can see an F-clip going right into the center of the jam and T-clip going in there. Same thing at the top. There's a gap because for movement and stuff, which I mimic the detail. And then the corner is also here. We're getting some notches from the server, but I'm just going to ignore those for now. I don't know how long this is supposed to be, actually. I just actually used the data that we have on the server for this thing, so and it looked pretty good. Gonna have to notch that out eventually. Also, I did the door. So I added these guys in here. These are the anchors that anchor the mullion. They're in the detail. They anchor the mullion to the floor, and I just added them directly on the vert tagline right here. Fixed length, bottom side. Did that for both of them, like that. I also, for the extended covers, all these verticals have extended covers. I added a cap. See if I can show you that. So I added a cap here at the end for each of them. That's what the detail said. I imagine that's true just because you don't want birds and stuff nesting inside of there. So so I had to make my own part for this cap. I've seen various ways of doing that, but for this one, I made the die drawing look like the shape, the actual profile shape of the cap, and then I told it that the length was 1/8. I've seen a lot of people go the other way where they'll just do like a rectangle. In this case, a 2.5 by 1/8 inch rectangle, and tell it that the length of the part is 6 inches or however big this cap is. And then they use notching in the fab ticket stage to make this thing look like that shape. I went the other way just because it was easier at the time, and we're not talking about fab tickets yet. So I wanted it to look right. But the other way is perfectly valid as well. I think that's it for all the weird miscellaneous stuff that I discovered and had to add in that I forgot. We did the door header clips last time, and another thing is on the pocket fillers. So I actually put them in here and I saved it this time. But I made this tagline so that there's no adjustments at all. So however long the tagline is how long the pocket filler is. And I kind of like doing that for things like pocket fillers, because making different uses for different adjustments is kind of crazy. So I made it exactly as long as I wanted it to go. So up here goes past the door header and up into the pocket, or up into the horizontal at the same level. Same with the other side. I wasn't sure where this vertical ends. According to the threshold detail here, 507, it goes all the way to the floor, but I think you want it to be held up so that they can caulk around it, also for that other angle. So as you can see in my BIM model, I left that door vertical level with the bottom of the sill, so that it could just track the caulking from here and around. I don't know if that's what you guys normally do. I'm pretty sure that's what we normally do in Fremont. And then, yeah, doors are always interesting. And I want to select this yellow line here as the pocket filler. So this is the pocket filler here. I just have it flush at the bottom and going up into a little bit into the horizontal. Another thing I did was on the pressure bars, all the horizontal pressure bars. In Fremont, at least, we leave them an 1/8 inch short of daylight so that they're easy to put in. They're not visible at all in the system, so they don't have to go all the way to the end. That's what I did there. And that's on just the horizontal ones. The vertical ones, I didn't do that. Though the vertical ones with the cap, so this is the vertical, and there's a cap in here. See, there's a cap. This is the cap. On top of the cap is the actual cover, this guy, and then this is the pressure bar. So because of the cap, I needed to hold the pressure bar back off the cap, so I made it a pretty big gap. But that's only on the top and bottom of the pressure bar with the hooks that gets the extended cover in the cap. The other ones I left flush, like the one at the jam is flush. The one at the vert, or that's not a vert. The one at the door over here is flush, because there's no cap there. And then the last interesting thing is the filler at the sill and the head. I have it right here. In Fremont, we leave it really short, so that it doesn't interfere with the T-clips and the F-clips. There's these things are screwed down, so there's a big bolt head right here, so which interferes with the filler. We leave them short. We usually go 7 inches short of daylight, so it misses this thing completely. And we just do 7 everywhere, even though you could probably get away with less at the T-clips, just to be consistent. So I got 7 inches short on the sills, and at the heads I have the same 7 inches short both ways, because even though it doesn't hit the bolt directly, any sort of movement or thermal expansion might make it hit, so we try and dodge them up there too. I don't know if you guys do that or not. At the corner, it's a different number. I think it's 14. That's what we do in Fremont, because the corner T-clip is bigger. It's 14 inches from the dim point back, and then that makes it so that it misses the T-clip. Might be a little hard to see. That looks like it hits it. Probably should pull it back further. Or, oh, that's right. At the corner, we don't have independent logic yet for horizontals at the corner, or sills or heads at the corner yet. Everything is getting cut the same way. So this one is still at 7 inches from the dim point. And that's what, and it's not mitered or anything. And we'll cover that later. For the metal takeoff, which is where we're trying to get to, we don't necessarily care that it's extra long, as long as we have enough material. We're getting like an extra clip here and there. It's overall, it's not going to make much of a difference on the whole building if we have a little overage like that. So that was kind of the weird, fun, interesting stuff that I ended up doing to my data. Hopefully you guys found the same things. Any questions about the homework or anything before we continue with the new content?
Nope.
Alrighty. So I didn't actually have this on the lesson plan originally, but then I realized that I probably should have something like this to go over how you release and optimize and what that actually means. Because this is the last step that we would need to finish a metal takeoff. So first of all, we got to talk about finishes. So far, everything that we've put in the UD window has had the finish of paint, and that isn't true. Paint is the most expensive finish that you could have on an extrusion. So I wrote up, we usually downgrade for things. So I wrote down this basic finish logic. You want to ask yourself, is it visible? And if that is yes, then yes, paint. You want to paint it. Does caulking, if it's not visible, then you kind of just continue to the next question. Does caulking need to stick to it? If that answer is yes, then we usually do Alodine for extrusions or Anodized for brake shapes. And the reason for Anodized for brake shapes is because you can buy brake metal that's already anodized. You could go Anodized also for extrusions, but I think Alodine is just cheaper. And if both of those questions, the answers to those questions are no, then you just do a mill finish. So we're going to do that really quick. One of the big things in this tech wall system are the shear block clips. These aren't visible. I don't know, caulking, we don't usually put caulking on these, do we? So these can just be mill. And I'd have to go through all of my data and make those all mill. The other thing is the pressure bar. Pressure bar is not visible. So if we look at it here, you can't see it. This cover completely hides it. There is caulking on it, so it might have to be Alodine. So we could make those Alodine. Sometimes we just make them paint up here. I don't know why, really. They probably could just be Alodine. I think there was an older version of the tech wall where this little part, this part was a little shorter and you could actually see the pressure bar, so we had to paint it. But with this system, I don't think you have to paint it because it's completely hidden. So this pressure bar here, I'll make that Alodine. The filler, now at the sill, the filler isn't visible. At the head, this filler isn't visible, but at the horizontals, it completely is visible. So we tend to make things, we don't want to have two different kinds of fillers that they have to sort through, as far as like some being painted, some being Alodine, or some being mill. So I'll just paint all of them. It makes it so that we have, if something happens and we run out of painted ones, we will have some more backups for painted fillers instead of having just a bunch of Alodine or mill fillers that we can't use at all. So Alodine on the pressure bars, mill on the shear block clips. There's a pressure bar here. Again, the filler here isn't visible on the jam, but And this trim here is a break shape. So, oh wait, no, that's not the one. That's on the interior of the building, so definitely both visible. This break shape is also visible on the outside, so paint there. And just kind of go through. You could do it while you're entering the original data. My caps are definitely painted, but they're painted after they're cut. They're going to cut it into that shape, and then they have to paint it so that there's no exposed edges. So usually in Fremont, we'll go post paint, something like that, to denote that it's painted after it's cut. That is the extended cover, so that should be painted horizontal. Alodine. Probably would have been better to do this before we made a whole bunch of copies of things, but good practice. So this DWC, if you look at the detail of this, is just an adapter that to attach the shear block or the SRT on. Again, not visible, no caulking, so we'll make that mill. If there's somewhere else on the building that you could see that, which shouldn't happen, then we'd probably upgrade that to paint or something else. Jam Alodine here. This is the horizontal above the door. Now there's a pocket filler channel here, so let's look at the details there to see what the finish might be. That was 507, right? Yeah. So here, it's not visible. There is caulking on it, so the best we can do here, the cheapest we can do here is Alodine. But I'm also using the same channel at the verticals, so let's take a look at the vertical detail as well. At the door. So again, not visible, caulking. So theoretically, we could probably go Alodine on this, but I don't know, that this might peak out somehow. Maybe over time, this moves around enough and maybe it exposes that. I don't know if I'm comfortable enough. There's not that much of this part. It seems reasonable just to paint it to make sure that there's never some kind of exposed edge there. The door head tube is definitely painted. These angles can be mill. There's no caulking on these. And you just go through the whole set like that. All right, I'm gonna stop there. The T-clips should probably all be, they shouldn't have caulking on them, so these are probably all mill too. All right. So that's all there is to doing finish. I mean, it's just going around the details and making sure that everything is, you choose it based on the logic. And it's a fairly simple logic. Sometimes there's caulking that isn't shown on the details, which you might have to consider. But you'll get the hang of that over time. All right, any questions about finishes? All right. Let's let's go on to releases. So now that we've done all the finishes, actually, let me first UPD this. I changed my data, so I want it to be up to date. I don't want everything to be paint. Right, and I'll close the BIM model here, because that BIM model's out of date as well. All right, so after that UPD, I should have everything in my takeoff program, all the parts and pieces. So we're gonna go over releases, and releases are groups, parts of the building that you're releasing in some way, like either to the shop or to the field or to purchasing or whatever. It is often confused with distribution, and they're two totally different concepts. Distribution is how parts are distributed to the field, like a delivery address. So the field may want the parts delivered on a per floor basis, like all the parts for the first floor go to the first floor. Parts for the second floor go to the second floor. That's fine and good, but it's not the same as releases. They may coincidentally be the same. Maybe you release the first floor and it's all delivered to the first floor, but that's two different things. The release is one thing and the distribution is another. So try not to get those confused. A lot of times we'll have releases with multiple distributions. Maybe you're releasing the whole building at once and the distributions are first floor, second floor, third floor. Maybe you're doing a release that's just the north side of the building and then the distributions are first floor, second floor, third floor, etc. There's a lot of different ways to slice it up. But as far as the takeoff program goes, releases have to be an entire elevation. So when we made our taglines, we assigned things to an elevation number. Everything on that same elevation number has to be released at the same time. You can't take half of one elevation in one release. It just won't let you do that unless you go through some great lengths. Distribution is a secondary piece of data that you put on your taglines, and we're not going to worry about it for the metal takeoff, but each of your taglines has a distribution index to indicate where it needs to be delivered to in the field. You cannot make a release based on distributions alone. So where's that other thing? Yeah. So the releases are always by whole elevations, and distributions are independent of it completely. Any questions about that? Because I know I get a lot of questions about that. So the typical setup that we do for stick wall or field use stuff in the takeoff program is we assign elevations to a group, a typical group. Then we create an area that includes one or more of those groups. And then we create a release that includes one area and the star location, which is any location. So we're going to do that here for elevation 2. So if I go to my takeoff program and I go to elevation info, we see the 3 elevations that we've tagged on this sheet. And there will be more of these if you had more than one sheet. Over here under typical group, everything is going under group 1 right now. So I want to do, let's say that we want to make a release of a single elevation. So I'm going to do a single elevation release of elevation 2. So I need to give it a group. Put elevation 2 in its own special group. I'll just call it LF2 for lack of a better name. So, and I'll do the same for the other ones. Why not? LF1. Maybe I shouldn't call it like that. Maybe that's a little misleading. Let's just call it group 1. Group 1, group 2. And just to make things interesting, for elevation 3, oops, this should have been group 2. For elevation 3, we'll also put that on group 1. Okay, so I'm basically telling the takeoff program that the elevation 1 and 3, they're part of the same kind of group of items. This could be like maybe north side of the building, it could be south wall, whatever. It could just be something generic if you want to release the whole building at once too. So I sliced it up a little bit like that. And then, so I got my elevations assigned to a typical group. Then we'll create an area that includes one or more groups. So I'm going to make an area, which is here under areas. And I deliberately made new group names because I wanted to make these from scratch. There's some default ones here, which you can probably ignore. So I'm going to make an area called group 1, or let's just call it area 1, so we don't get confused. Area 1 is going to consist of group 1. So if I choose area 1, it's going to be everything that's in group 1, which is elevations 1 and 3. Area 2 will be group 2, and the only thing in group 2 is elevation 2. And then I can make one called everything. And area everything will have group 1 in it. And area everything, just have to type it out again, also has group 2 in it. So now I have 3 areas that I've defined here. Area 1 is group 1, area 2 is group 2, and everything has both 1 and 2. That's why there's a distinction between groups and areas, so you can kind of do things like this. All right, so now that I have the areas set up, now we need to create releases that includes one area and the star location. So up here is where the release stuff is. I don't know how much you guys actually use this. Hopefully you'll start using it because it's really kind of handy, especially when with multiple people. But if you click on this drop down here, there's a little edit box. It's hard to see, but it's there. If you open this and then you wheel with your mouse, this box will disappear like that. Not good. So you just close it, pull it up again. All right, so this is the releases. A release is a combination of an area and a location. So if I want my area 1, I'll just call it release 1. Release 1 will be using area 1, which is elevations 1 and 2, or 1 and 3, and location star. Release 2 will be my second elevation, which is area 2, and star here. And then if I wanted to make a release of everything, let's just call it big release. I can choose my everything area and star. Once you have that set up, all you have to do to get those specific filters is use this drop down. So if I go here and I choose release 1, I'm going to have my 2 elevations in it, elevations 1 and 2, or 1 and 3, sorry. If I go to release 2, I'll have my 1 elevation, which is elevation 2. And then if I go to big release, I'll get all 3 elevations. And it's as simple as that. What's happening when you go up here and clicking on one of these is it's changing your elevation info to copy these typical groups over to group and letting the processing happen. Then if you're used to dealing with just the group column, the Takeoff program kind of treats that as a temporary column. This column can change every time you UPD. It sets the group of whatever elevations you're UPDing in to X. So the information in this column gets destroyed every time people UPD. But the stuff in here stays. Like it never gets changed unless someone types something else. So that's why you want to fill out typical group. And the Takeoff program will deal with the whole copying this over to group and all that stuff. There's also some other pre-made releases in here. Last UPD is the last thing you UPD'd. And for us, it was that sheet 205, which has the 3 elevations in it. That one's a special release that's always there. There's a couple other ones, but you can just probably ignore or erase those. They were geared pretty much to Fremont's old process of metal takeoff, which we're not even using anymore. So yeah, you can just ignore them and make your own release names. Also notice that when I pick a release name, the name of it appears up here at the top. So now this is Training Project Release 1, which is also very handy. This will also appear on all of your outputs. If I made a metal order, it's going to say that release name in the file name automatically without me having to type it out. All right. So that's pretty much all oh, well, that's just for stick wall. For units, it's a little different. Usually we set up the units so that they all are in the same group called unit, and it will be like that automatically as you're UPDing units. And then the instances of the units, the individual items, the individual, I guess, instances of the unit are set to a specific location based on, for Fremont, we use a pallet schedule to order the units in a specific order. You guys are probably used to using the unit release on the tag. So when you have a unit tag, there's a piece of data called unit release where you can type in whatever release that unit is supposed to be a part of. And that will appear when after UPD under the unit itself. It'll be over here in the location plus the sheet number, I believe. So that's why for units, when you create the release, you usually just include the area units, which is all the units on the entire building, and then you use the location. You make a location filter for that. So if I click over here, there's a couple, I guess there's no examples here. So let's just say we were doing units week. We usually do our units by week or something. So units week 1 would be the units area plus a filter like W1/*. So if we had some units in this job, this would probably make a little more sense. But this week 1 here would be the unit release that you typed on the unit tag. And then /* would be, usually the location has the DWG name here. So separated by a slash. So I want to incorporate that just so that I don't pull stuff from like week 10 or 11 or something. If I just did this, it would be weeks 1, 10, 11, 12, that kind of stuff. So usually do that. * means any characters, any number of characters afterwards, after this slash. So this would just pull units week 1, units week 2 would look something, I mean, obviously it's going to be like this. And then if you were doing something like, I want to release weeks 1 through 5, you can do that too. You just go unit weeks 1-5 /*. So you could do fancy stuff like that. The square brackets here indicate that this is only going to be one character, and it has to be a 1, 2, 3, 4, all the way up to 5. And then * again is anything after that. So you can set up more complicated release structures like that too. But those are just tricks. Yeah, that's pretty much all I wanted to go over about releases. It's all based off of groups, and areas into releases, and then location possibly if you're dealing with units. Any questions about that? I'm sure there will be when you try and set one of these up.
Where was the edit releases again?
So you click on the drop down for current release, and then there's this kind of phantom button in the lower left corner of the drop down list. If you wheel, that button disappears. So make sure you don't use your mouse wheel. And it should be there.
Got it, thanks.
Yep. You can also get to it if you hit F11. It's under releases here on the tables. Same thing. I don't encourage you to hit F11 and look at things, but sometimes people have problems finding that little button. So I think you might actually even be able to right click here and edit list items. There you go. Good. All right, any other questions? So one of your homework assignments will be to set up a release for just elevation 2. So basically did that in this video. You can just follow along if you didn't already. All right, let's talk about optimization. So optimization is kind of misunderstood, but when you think about it for a minute, it makes sense. So we have to order our parts in stock lengths, and they're already pre-cut coming from the extruder. And usually we order them at a large size, usually like say 20, 25 feet or so. But so say let's take for example a horizontal part. So we order a stock length of horizontal, and say the stock length is about 25 feet long, and most of the horizontals that we need to cut are 5 feet long. So we can put about 5 of them per stock length, and we don't have very much waste at all. But say we didn't order 25-foot stock lengths. Say we ordered 24-foot stock lengths. Now we can only put 4 horizontals per stock length, and we're losing 4 foot of material because we don't have any horizontals of that size. So optimization, all of our parts are always all these different sizes. Our bays aren't necessarily always 5 feet. So there's a bunch of different lengths that we have to deal with, and a huge quantity of them. And we want to figure out what is the most efficient stock length size to order so that we will minimize the amount of lost metal, because we can't like individually cater. We can't order one of each different stock length size that we need. Like it just gets crazy. So that's what optimization is. It's determine the optimal stock length size for each part to minimize the waste. And the program will do that for you. Stock length sizes may also be, there's some other considerations there. Sometimes we're limited by the extruder. First of all, doesn't really want to send us anything longer than 25-ish feet. It becomes harder for them to deal with. We don't like to have things that long either because they're hard to load into the Quadra, and I believe you guys have a Quadra, right? But like some other machines might have different limitations. We over here in Fremont have the Planet, and the Planet, depending on the part, we don't really want long parts on the Planet. So there may be considerations like that. Some parts are flimsy as well. So you could, like if you just look at the details that we were looking at, the pressure bar on the TechWall system is it's pretty thin. This thing here, it's pretty thin. Same with the extended cover. They're both pretty thin. They'll be pretty flimsy. If we order 25-foot stock lengths of this, it'll be flopping around like a fish when you're trying to load this into a machine or just handle it in any way, which could cause damage. It could get bent or something like that. So there may be considerations like that. Maybe certain parts you don't want to order 25 foot. You want something closer to 15, something like that. Typically, we deal with stock length sizes that are somewhere between 15 feet and 25 feet, depending on some of these considerations. I don't know if you guys have a specific sort of place where it lists these kind of considerations, or if you have a specific person that checks if stock lengths are the right size or will work on the machine. We have some guidelines on our wiki site that we go off of. Let me see if I can pull that up. I think it's in our standard procedures takeoff. Of course it's not there. Or maybe it is. Yeah, metal takeoff. So I I have this wiki page that lists kind of the steps to do a metal takeoff, at least for Fremont. And it lists a bunch of stock length sizes, stock length size considerations. We have a material kickoff meeting that may have some limitations. Paint finishes and cost may be different for lengths over 25 feet. So that's why another reason we don't want to go over 25. Most parts should be shorter than 24'2" for fabrication on the Quadra. SAPA has their own requirements. SAPA recommends the following parts don't exceed lengths between 15 and 20 feet. And here's a whole list of part numbers that SAPA doesn't want us to go over 20 feet with those. So yeah, and then we also have someone that reviews these. We're supposed to send our stock length sizes to Tony and Heather. Tony is our machine programming guy, and Heather is our salesperson, or purchasing person who purchases the metal from the vendor. And they make sure that whatever the metal takeoff stock length sizes are, that they're good for their processes. So there could be a lot of different considerations there. Also, a lot of times with verticals on buildings, we'll have two primary lengths for the verticals. Usually the first floor of a building is bigger than the other floors or taller. So our verticals on the first floor tend to be, I don't know, 15, 16 feet. But then on the other floors, it might only be 13 feet, which kind of wreaks havoc with our optimizations. And we're going to actually see that probably on this job, because these verticals here on our elevation 2, they're about 15 feet long. But then over here, we have a splice here, which makes this 16 feet. But then up here, this vertical is about 21'8". So if we were doing verticals on a stock length that's about 22 feet long, we can put one of these, but we can only put one of these as well, and we'll end up losing about 6 feet of material on each one of these verticals, and there's plenty of them, right? So a lot of times with verticals, if we get a bad yield on the optimization, we'll tend to use two stock length sizes. We'll just order both about a 15-footer and about a 22-footer or something like that, so that it covers the whole job. And that's not just the verticals. It's probably going to happen on this job to the pressure bars, probably to the extended covers and the smaller cover as well. So that's kind of a last resort, but we'll go over that very shortly here. So the way we optimize in the Takeoff program is we go to we set up our filter first. So for the metal takeoff, we'll usually do everything. So let's do the big release. So we'll have all three of our elevations in here. And then you go over here to do optimize extrusions. You don't want to have different stock length sizes for each release that you're going to end up doing, because that's just not how we order metal. So I'm going to try and figure out how long my stock lengths are for the whole release, and then we'll talk about maybe breaking up the releases into something smaller. So I'm going to hit optimize extrusions, and you have this window here. This is the first time I'm running optimization, so I want it to figure out how the best size for everything. So I'm going to click on this automatically generate sizes. When you run it with the automatically generate sizes, it's going to erase whatever stock length sizes it was using before. So you usually only want to do this on the very first time you run optimization. After that, you're going to kind of refine your stock length sizes, and you don't want it to erase them all by checking this box again. There's also 3 different versions of the optimization in increasing order of kind of tightness. Estimate kind of rounds everything up to the whole inch and then adds 6 inches. It's like very fluffy. Takeoff one rounds everything up to a whole inch, and then adds in for the saw cuts. And I think it might add a couple inches if it's an odd number or something like that, but this one's a lot tighter than the estimate. And then fabricate is for the real deal. This is what you're doing for the actual release. And usually you only use this when you're releasing fabrication tickets. We're doing a metal takeoff, so we're going to do this here. And then the different optimization styles I outlined in the outline, the different optimization styles that we use. Original is very simple. It doesn't consider cutting orders at all, and it just tries to figure out the best way to do the entire job all at once. If you use the stick wall field use one, it tries to optimize everything so that from a single stock length, you cut all the parts from that stock length go to a specific distribution. And then until that distribution is completely finished and packaged, and then it'll start cutting the next distribution. So this is really good for the shop because they don't have, when you do an optimization like this, the cut lists are in some random order, and the shop who's trying to fill that, trying to follow that cut list will end up with a big pile of metal at the end, and which they'll have to sort through so that they can divide it up into packages to go to the different distributions on the building. Whereas this one, they just follow the cut list, and everything in that cut list will go to, say, floor one. They can put it on a pallet as they cut it, and then once they're done with the floor one part of the cut list, they can wrap that up and send it off. So there's no sorting afterwards. There's a little bit more waste in the optimization process because it's not completely 100% minimized waste, but it's close enough, and the benefits outweigh the losses. The other one that you may use is unit assembly by pallet, which is for fabrication in Fremont. And that uses the pallet schedule to cut everything in the order of the pallet schedule. You also have unit assembly by day. I didn't put it on here. I'll add it in later. But there's also unit assembly by day, which is similar. It doesn't use a pallet schedule. It uses a specific unit release naming structure to order them by day. And that's what you guys use for units. So for this, I'm just going to use original. I don't have the whole building in here anyway, so original seems fine for now. I also don't have distribution, so it shouldn't make any difference if I choose any of these other ones. All right, so it's trying to figure out the best stock length sizes, and the way it does that is it just tries them all. It starts at like 185 inches and goes up to 305 inches and tries to figure out which one was the best one with the least waste. So these are the stock length sizes that it figured out here. It also takes into consideration standard lengths that we may have. So on the server, there's data that says that the standard lengths for certain parts are X and X. So you can see those here. And that's because we stock these parts, at least Fremont stocks these parts. They're also marked in blue here. But you can, this here is what it is actually going to cut, or what it's actually going to use for the optimization. So this all looks fine for now. We'll see how this looks in the next page, but if you needed to manipulate this is where you would do it. This thing is too long here. We said 290 was about the max. This is also a flimsy part, so maybe we want to go down to, let's just play with this number, and we'll make it, I don't know, let's just make it 200 inches and see what happens. Now, the reason why this was red is because this is too long for the quadra. So bump that down a bit. I'll hit OK. Oh, I apparently have some really long pieces. So what were those part numbers? T604 5521. That's that part. So I guess I have a piece. It's probably on one of those other elevations that doesn't fit on a 200-inch long stock length. Oh, it's probably on that vertical, that long vertical. So I'll just leave it at 302. Heck. Or I can look at the vertical 267. That should cover it. All right, okay. And then it goes off and it optimizes with those stock length sizes in mind. And it gives me this little report here, which tells me the yield percentage is the main number here. So what that means is 97% of this stock length is getting used and only 3% is getting lost to the saw cuts and to large drops. So there isn't very much metal in this because we only got one page, but you can see that there might be a problem already with this vertical. Like I mentioned before, this 73% is pretty bad. We're throwing away a lot, and I mentioned earlier that we're probably going to need a 22-foot stock length for that part, just for that upper floor of the 2-span curtain wall on elevation 1, and then this is a really bad stock length for all the 15-foot, 16-foot ones that we have everywhere else. So this is a very good candidate for having 2 stock length sizes to bring this yield into something normal. This thing also makes, I mean, this is basically a guess number. It's probably based on aluminum prices from like 6 years ago. But it just gives you kind of a feel for how much waste that is. 73% is bad when you have 29 stock lengths or a lot of stock lengths. If it was 73% on a single stock length, you almost don't care because it's not that much money. So that's what this dollar value kind of helps you get a feel for, is how much waste actually is there. These percentages here, 81%, are pretty low, but it results in a little dollar value because there's not very many of those stock lengths. Whereas this 74%, this part is light, so it doesn't cost that much. So even though there's 26 stock lengths here, they don't weigh very much. So even though 74% doesn't result in too much dollar value wasted. So I'm going to do something about this 5100. I'm going to put that on 2 stock length sizes. And usually when you have to do that, you can look at the elevations and make a guess. So we know that these are about 20, it wants to do a 22.3 for this long piece of vertical here. But I'm going to need something this is my next longest vertical, I think, because this is still about 15 feet. So I'm going to also give it like one that's 16 foot and some change for my second stock length size. So I'm going to run it again. Doing original, not automatically generating sizes. Brings me right to this window where I can change the numbers. So T754 5100, I'm going to keep this 267-inch one, and I'm going to add another one over here. This is the second stock length size. So 16 feet is what, 192? I want it to be a little longer than that, so I'll give it another 6 inches or so. So 198 sounds like a decent number. I'll hit OK. And then we'll see what my yields end up being. So now I have some of the T754 5100s going on this 16-foot stock length size, 16'6", and I have some of them going to 22'3", and their percentages are 90 and 86, which is much better. I was losing $1,500. Now I'm only losing about $500. So made a big difference there. And you can play with those numbers a little more to get it tighter. Usually you want verticals to be around 90%. It's really hard to get them up higher than 90%, depending on the job. For horizontals, 95, 98, those are pretty good numbers. Horizontals are easier to optimize because they're shorter and there's more of them. So you can usually find a short horizontal to stick at the end of any bar, so there's less waste. So there we go. That's the optimization. Any questions about that process? We went over it pretty fast. All right, so we're going to make some outputs here in the last few minutes. So there's two outputs. Once you've done this optimization, there's the metal order form output, which you get to by running this. And it defaults into the materials released to PM folder where your takeoff program is. And notice it puts big release here because that's the name of my big release, and it also puts the date. So I usually don't mess with the names here because that's pretty good. That's one output. And then the other one is the metal takeoff form. So I haven't run this from this computer, so hopefully there's no issues. There we go. You can ignore this. It's not actually going to send anything through Outlook. I should probably remove that. And then metal takeoff form. It's called metal takeoff summary. Just save it in the same place. And then I'll open these up. Trying to move this window over. All right. So here's my metal order form, big release. Looks like this. It lists all the parts in here, their lengths, their finishes. You just use this letter, look up here. Type A is Alodine, etc. This is the actual quantity here that the takeoff program thinks you'll need. There's a formula to add extras in case of damage or shop mistakes or whatever. And this quantity is what we'll actually order. So that will come into play probably later when we do Fabs. You want to make sure that whatever you're releasing, there's probably enough metal for it. And you want to discover what sort of metal shortages you may have as early as you possibly can. So we usually save these metal orders for ourselves, and they're usually by week for us for units. And then as we're releasing the units for Fabs, we compare what we're releasing to what we ordered and make sure everything's on track. And if it starts to deviate too much, then we have to tell the PM, you got to order more metal because we're probably going to run out. So that's something we do in engineering up here in Fremont. Don't know about you guys. Metal takeoff summary is very similar to that page we were getting in the takeoff program. It shows the yields, but it also has a few other tabs here. Under metal takeoff, it lists every single piece with its mark number and length. And then there's also this stock length recap, which is basically a shortened version of the cut list. And it tells you, it gives you an idea of how many of each cut or each size part you have. So sometimes if you have, I mean, we only had one elevation, so it was really easy to find out what those two stock length sizes should have been for the 5100. But you can come here and you can look at these stock lengths or the actual part sizes here and determine 196 plus a few inches probably would be a good stock length size, and then the 163 there for the other one. You can also use this list to do that. Filter by a specific part number. Like this. And you can see all the stock or all the parts that you have and their relative quantities here. 12 of these, 5 of these, whatever, so that you can figure out exactly what you want to do. All right. Any questions about making those outputs? It really is just click and save.
Nope.
All right, so it's lunchtime. Your homework for Monday is to update all the finishes on all the parts and create a release that only includes elevation 2. You probably just want to create all the releases that I made there, and then optimize to create the metal order form for elevation 2. And that's it. And next week we'll move on to Fabs. That pretty much concludes the metal takeoff part of things. We're going to start getting more refined data, get the correct lengths, and work on the fab templates, get all the notches in there and that kind of stuff. So this is when the fun stuff starts to happen. All right. Cool, guys. I hope that all made sense, and I'll see you on Monday.
Thanks, Zach. Appreciate it.
No problem.
Thanks.